Hey guys, today I'm going to teach you how to solve systems of equations by substitution part 2. So make sure you've watched part 1 before you check this out. By the end of this lesson, you'll be able to solve systems by substitution to determine how many solutions a system has. So again, is it no solutions, one solution, or infinitely many solutions? And we'll recognize that by doing algebra, not by graphing. So go ahead and go to your binder, turn to the math section, and get ready to take some notes. So as you know, a system of equations is two or more lines in a coordinate plane, and we're looking at them at the same time. A system has a solution at the point where they intersect. So you should already know that a system of linear equations might have one solution if they intersect at one point, no solution if the lines are parallel, and then infinitely many solutions if the lines are on top of each other. So here we go with substitution. So your friend is solving an equation, and her last line of work says 2 equals 2. What does this mean? Let me show you what this might mean in an example. Let's get yourself warmed up by solving this system of equations by substitution. So use what we know in our last lesson about substitution to try to solve this by yourself. And then I'll walk you through it, and then we'll see if we can figure out what that girl just did whenever she got to the last line and had a 2 equals 2. Let's see what we got here. So remember, the first step is to get one of your equations set to a y equals. This one already is, so I can just substitute what y equals into the y in the other equation. So if that y is negative 2x plus 5, I'm going to rewrite the first equation as, let me draw a line here, 4x plus 2, and then instead of y, I'm going to use what I know that y equals in that other blue box. So now that it's written in one variable, I can solve this. So I'll draw my line on the equals. I'll distribute that 2, since it's on the outside of it in parentheses. Remember, it's multiplying by the whole thing. So I have a negative 4x plus 10 after I distribute, and I have a 4x here on the outside. So if you haven't already, please try this next part by yourself. Everybody should be able to do this from here on out. So here on out, it's just a equation where there's only one variable. I need to get my x's on one side, my numbers on the other, yada yada. I want to simplify by combining like terms if I can. So when I look on the left here, I see I have 4x minus 4x. So I'm going to take that away because 4x's minus 4x's is nothing. And I'm left with 10 equals 10. Huh? What do I do with that? This is the problem that this girl ran into whenever she did her work. She got the same thing. She got a 2 equals 2. What in the world does that mean at your last line? Let's try to use graphing to maybe see what happened here. First line is going to be red, and so this red line represents the graph of this line. Let's look at the blue line. Blue line is going to be the second equation. You can see the blue line is here, and you should notice that these look very similar. These look exactly the same. In fact, if I show you both lines at once, it's going to look like one of the lines disappeared. What actually happened is they are on top of each other. These are the same equations of the same line. So what that means is when you're solving an equation by substitution and you get to the last line and you get a 2 equals 2 or a 10 equals 10, when that number equals that other number, that means that the equation has infinitely many solutions. It means that they are the same line. Here's another example. It says, as your friend is solving a different equation and the last line of work says 2 equals 1, what does that mean? Whenever you get a number doesn't equal the other number. Let me show you another example where this might happen. Here's a different example with two different equations. I have this first equation and the second equation. One of them is already set, y equals. So what I can do is, just like last time when I solved for substitution, you can try this by yourself also. Please pause the video and try this by yourself if you feel like you can do this. At least try it and then press play and check it with me and go step by step. If this y equals negative 3x plus 3, then this y equals negative 3x plus 3. So I'm going to rewrite the first equation in terms of that. So 6x plus 2, and instead of writing y, I'm going to write negative 3x plus 3, because that y is the same as this, since that y is the same as this. Equals 1, and then I do that because now I only have one variable, x, and it's written in one equation, so I can solve for it now. So I'm going to draw my line on the equals, and then I'm going to start by distributing that 2 to each term on the inside. So I have a negative 6x plus 6, and I have a 6x on the outside here. That equals 1. So finish this out by yourself if you can. So what I have here left is a 6x plus negative 6x. Those are like terms, and they cancel each other out. So I'm left with a 6 equals 1. Huh? 6 don't equal 1? What are you talking about? Same thing that this girl is saying. So she says she got a 2 equals 1 on the end of her graph. Let's look at this and see if we can figure out what happened here. This is what I got when I graphed them. This is the red line. This is the blue line. And if you notice, they are parallel. These are actually going to have the same slope if they were written in slope-intercept form. Because this is written in standard form, you might not have seen that right off the bat. That's why substitution can be helpful, is that sometimes you can do what you can't necessarily see right away whenever you might look at these two lines. So, that being said, when I got to the bottom there, and I got a number that doesn't equal the other number, the equation has no solution. That means that the lines are parallel. So the new thing we learned today in part 2 is that when we solve by substitution, we can get 3 different options. One thing we might see, like last time, is we would get x equals a number and y equals a number. That's when they intersect at one point. The second thing we see today is when you get to the end of your solving and you have a number equals that same number. That means the equation has infinitely many solutions. That means that they are the same line, and you would write infinitely many solutions as the answer. The third thing you might see is that you might get a number equals a different number. If you get that, it means that no matter what you put in for x and y, it'll never work. The equation will have no solution. So it doesn't matter whichever point you choose for x and y, it will never ever work because the lines are never touching. They're parallel lines. So you would write D and E, or does not exist, or you could also write the equation has no solution. So those are your 3 options for writing what the answer to a system of equations is when you are solving. It could either be a point, no solution, or infinitely many solutions. And here is 2 more examples for you to look at, for you to try by yourself, of times where that might happen. All right, guys, that's it. If you made it to the end of this video, please put in the comments your favorite prime number. Today we finished solving systems by substitution. That was part 2, and that's the last part. So hopefully this worked out for you. If it didn't, there's one more strategy we're going to use to solve systems of equation called elimination, and that will be in our next video. But now you should be able to solve systems by substitution and determine, using substitution, how many solutions a system has. Is it infinitely many? Do they not exist? Or is there one? Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.